So when it comes to inequalities, if you're doing this on your study sheet, you can add to your study sheet. If not, you want to use the front of your cover or the back of your cover, wherever you feel like you want to start collecting this information.
Excuse the interruption. Gabriel Pierre to room 48, please. Gabriel Pierre to room 48.
All right. So when it comes to inequalities, we want to always clean it up. Okay. So if you have, 3x minus 4y, is greater than or equal to 5x plus y. Let's go negative 10, negative 12, let's go like that. If you have that ever, you want to clean up. Okay? And by clean up, I mean you want a number x plus a number y is greater than or equal to a number. Okay? That's, in general, what we're going to attempt to do. Now, this is oversimplified. Sometimes you only have x left. Sometimes you only have y left. We'll deal with those in a bit. Okay? So in this particular case, I will just say that, right, I'll bring the 5x over to this side, and I'll bring the y over to this side. So it ends up being 3x. Let me zoom into that part. 3x minus 5x minus 4y. And the y is positive on this side. If it comes over, it's negative. And the inequality stays the same, minus 12. Sorry, I should have made the y. It's going crazy. Hold on, let me see if I can, yeah, there we go. And then just combine them, okay? So negative 2x, this would be negative 5y, greater than or equal to negative 12. So this is what you want to try to do if it's not already done. If it's already cleaned up, then you're good to go. Okay? And then find the x-intercepts, right? So x-intercept, y-intercept, and we're going to do a lot of this. So, okay, x-intercept, you let y equal to 0. Y-intercept, you let x equal to 0. Okay, so this would be negative 2x is equal to negative 12. You go divide by negative 2. X is equal to 6, so 6, 0. Okay. And then on the other side, you let x equal to 0, so it's negative 5y is equal to negative 12. You divide both sides by negative 5. Y is equal to, when it's like this, I would just say, right, double negative turns into positive. You go 12 divided by 5, which is 2.4 in this case. So it's 0, 2.4. Okay. You're going to do this over and over again, so might as well have that on your study sheet. When we rewrite, okay, rewrite to graph. Actually, I should say rewrite to shade. We'll do that because you can technically graph without rewriting, but this step, guys, you want to rewrite because we're going to enter that into our calculator. Okay, we're going to enter a bunch of inequalities into our calculator at the same time, okay? So you take the negative 2x minus 5y greater than or equal to negative 12. And I'm doing a whole bunch of things at the same time. I'm reviewing. I'm asking you to add this to your study sheet. Maybe you already have something on your study sheet. That's great. So when you rewrite, after you've cleaned up, you basically want to isolate y, right? So we're going to bring this negative 2x over to the other side. So we end up with negative 5y is greater than or equal to 2x minus 12. And what's the next step? Let's see if you're awake. What is our next step at this point? Yeah.
Divide everything by -5.
That's right. Divide everything by negative 5, because that's what's in front of y. And in this case, because we're dividing by negative 5, what is something we need to watch out for? The inequality symbol flips in this case, okay? So flip, we're going to make it go the other way. But some of you have been wondering, like, when do I flip? It's because we're dividing by negative, okay? Divide by a negative. That's why we're flipping, okay? And then it's 2 divided by negative 5, which is negative 2 over 5x. Watch this one. Negative 12 divided by negative 5 is just positive. I'm going to encourage you to leave this as a fraction, okay? This is why, because this is most like, it could very well be that this is a decimal that doesn't end, okay? So I would like you to enter that into your calculators like that. So what I do is I put brackets around this at the end, right? And I also put brackets around this when I enter it. So if you have fractions, use brackets and then you're good to go, okay? Now a couple of things. When you graph this, okay, I'm going to do that on the side here for shading, okay? Determining true region. This is the important part, true region. That's the one I need you to find out. You need to know where is the true region. Let me zoom out a bit. You need to know where's the true region. I don't care which one you end up shading, as long as you're consistent. I'm going to suggest reverse shading every time. Okay. So if it's y less than, or y is less than or equal to, okay, then it's below the line. True is below. Okay. So my key, you will see me go true is like this, T is below. This is what I will show you to indicate that where's the true region. So if you have your line like this, and this is the diagonal, true is below. Okay. I'll give you several versions of a line. Okay, you've got the diagonal lines. And don't forget your special case. There could be a horizontal line. You could end up with a horizontal line. And in every single one of these cases, true is below that line. So you might have one that drops from left to right. You might have one that increases from left to right. And you might have a horizontal line. Okay? And if y is greater than, right, or greater than or equal to, right, true is above. So true is above the line. And I'll give you the three cases again. You could have a line that goes up, a line that goes down, and a line that's perfectly horizontal. And so true is above. That is non-disputable. The true region is always found the same way, okay? But there's one more case that you need to consider. So we've got both of these where you will have a y isolated, okay? The last one is if you end up with an x only. Okay? If you end up with x is greater than, or x is greater than or equal to, true is right. And the only case that you have to consider is where you have a vertical line and the true region is here. If x is less than or x is less than or equal to, true is left. True. Okay, is left. This is my what I'm going to use to indicate this when I work with inequalities. I'm circling them. Okay. Fun stuff, eh? Just before summer break, we're talking about inequalities. I hear ya. I'm going to try to make it as least painful as possible. There's one more thing. I don't want to necessarily take up more space. The dashed versus solid, okay? So this is what I'm going to do. I'm grabbing a red pen, and I'm just going to go somewhere in here. Maybe here. Okay, if it's like this or like this, that's solid. If it's like this or like this, it's a dashed line. Somewhere in it's gonna be half a mark. So if you miss this, your graph, you will lose half a mark. So it's not going to be affecting you a whole lot, but you know, if you want full marks, then you would have to watch out for that. So this one right here, we could tell a bunch of things already. We know this is a solid line. We know that true is below the line. Okay, so this one right here is solid, right? True region is below the line. That's what I do every single time I rewrite. I tell myself that what type of line, where is the true region? And this is going to be the third item. I need you to pay attention to this one, okay? The true region is below the line, okay? but we're using reverse shading. For systems in particular, I'm using reverse shading. If the true is below the line, but I'm using reverse shading, I'm shading the false region, right? Where would I shade here? The exact opposite, right? So if the true region is below, I will shade above. And I just make a note of this because later when you graph, you're going to come back and just quickly tell yourself, okay, solid line, true is below, I got to shade above. And trust me, if you have 2 or 3 at the same time, this is going to be very helpful so you don't mix them up later. Okay? So this is something that I put down right away. Okay? All right. I think this does it for now. If you want to later come and take a picture of it because you just want to pay attention, or I'm also going to post a video, so if you want to watch it later, that's cool with me. All right.